Okay, we're going to look at collision theory and reaction rates, but we're going to use a metaphor of collisions on the road to help us explain what happens in a chemical reaction. The video we're looking at here is a number of vehicles on the road having collisions at high speed. So we'll use that as our metaphor. In chemistry, however, we regard a successful collision between particles as one that leads to a reaction occurring. In other words, ones that leads to bonds being broken and made. Let's define successful collision on the road as one that leads to a fatality. Now, in most instances that wouldn't be regarded as successful, but for our purposes here, that's what we'll be looking at. So what would increase our chances of having a successful fatal collision on the road? Well, surely if you had more vehicles, or at least a greater density of them, you're going to have a greater chance of a collision, and if you've got a greater chance of collision, therefore you should have a greater chance of a successful collision occurring. In a chemical situation, that's equivalent to increasing the number of reactant molecules in a given volume. We can increase that concentration or that pressure by either putting more particles into the volume or just decreasing the volume with the same number of particles in there. Both leads to an increase in concentration or pressure, which will lead to an increase in collisions between particles and therefore hopefully more successful collisions. If we're looking at the road, another way of a successful collision occurring on the road is if each vehicle on the road was travelling at a greater velocity. Not only would you increase the chance of collision, but there'd be more of those collisions would be successful, in other words fatal. In a chemical situation, we're looking at temperature, because a raising of temperature would raise your average kinetic energy of the particles. If you raise the kinetic energy of the particles, there's going to be more collisions, and more of those collisions will be successful. Another thing could be if the road or the vehicles were in some sort of dodgy condition, then that would mean there'd be a greater chance that the collision would be successful. In other words, they probably wouldn't have to be travelling as fast if their seatbelts weren't effective, or if they're a rusted vehicle or something along those lines. In a chemical situation, we can look at a thing called a catalyst, which will provide an alternative lower energy reaction pathway. This little animation shows nitrogen and hydrogen on an iron oxide catalyst. It enables the formation of ammonia at a lower energy than would happen without the catalyst being present. Another thing to consider on the roads is head-on or side-on collisions will give you different chances of a successful collision occurring. However, you must remember that a fatal collision will occur in any orientation if there is enough energy in the collision which does occur, and this will also apply to the chemical situation. But in a chemical situation, we do have to consider orientation. The orientation with which they collide will determine the minimum energy that is required for the bonds to be broken and made. In this little animation, that orientation that is just there at the moment would have a lower energy for a successful collision than any of the other orientations we saw previously. So essentially, we've got to increase the chance of a collision and also increase the likelihood that that collision will have enough energy to be successful. That relates to either on the road or in a chemical situation. Now, that particular amount of energy that is the energy required for a successful collision in chemistry is called the activation energy. A little animation here of methane and oxygen. The oxygen are the red particles and the methane is represented by the grey. If they just bond at low temperature, nothing happens. If you raise the temperature and give them enough energy, the activation energy, they will be able to react. And when they react, they actually release energy and provide energy for other particles to react as well. This is called an exothermic reaction because it's giving out energy. Energy is exiting.